Hello everyone. So in this video we are going to discuss this problem, and this problem was asked in 2026, means this year, in paper 1 in JEE Advanced. So the question is from trigonometry. So if you want to give the attempt, that will be more appreciated, and then we will see the solution. So for this particular question I'm going to give or present two different solutions for this. I invite you to join both of the solutions. The second solution I'm going to present involves the complex number, the theory of equation, and many other things, maybe binomial theorem also. We'll see what are the other mathematics we are going to involve in the second solution. So the first solution is very straightforward. That's I have written all the possible steps for that. So the first solution is for pure trigonometry. So the question is actually first, is alpha is an expression of the product of some trigonometric terms. So 1 minus 2 cos pi by 11, 1 minus 2 cos 3 pi by 11, and so on up to 81 pi by 11. You can notice this is geometric progression. You can see the angle is moving. So I can just write the product of 5 terms starting from r is equal to 0 to 4, and the term directly, or the general term, I can write as 1 minus 2 cos 3 to the power r pi by 11. You have encountered this kind of situation possibly many times if you are practicing trigonometry. This you can write, the cosine theta I can write by using this property or this formula. Cosine 2a is equal to 2 cosine squared a minus 1. This I can use, and I can write this thing as 2 cos squared theta by 2, because this is here a, so this is going to be a by 2, so this will become pi by 22. And further, after simplification, I get this 1 with minus 2 into minus 1, that will become plus 2. So 1 plus 2 will become 3, and this will become 4 cos square 3 to the power r pi by 22. Now, this kind of expression you have seen a little bit familiar. How we can notice that this is going to be 3 cosine a minus 4 cosine square cosine cube a. So that is going to be the cosine 3 theta or 3a. So for that purpose I am going to multiply and divide by this. I have multiplied by cosine 3 to the power r pi by 22 and divide by the same quantity. So this will turn into cosine 3a, that means cosine 3 to the power r plus 1 pi by 22, and this is already there. After this we can open this product and see what are the consequences. So the first term will going to be cosine of 3 pi by 22. So let us just take theta is equal to pi by 22, so that I don't have to write pi by 22 every time. So that is going to be cosine 3 theta, and denominator, that is cosine theta only. The second term will be cosine, because we are substituting r is equal to 1 there, so it become 3 square, that is 9. So cosine 9 theta and by cosine 3 theta. Similarly, cosine 27 theta by cosine 9 theta, then cosine 81 theta by cosine 27 theta, and finally cosine 243 theta divided by cosine 81 theta. It's a kind of multiplication telescopic, so we can just cancel these terms like this, and we are left with cosine 243 theta divided by cosine theta. But notice I have theta is pi by 22, so I can write cosine 243 pi by 22 divided by cosine pi by 22. Now this 243 is one more than the multiple of 22. We can see that this is 11 times pi plus pi by 22. And how I come to know? It's not difficult, because you notice that this is 11 pi into 22 is 242. And so I can write this as a cosine of 11 pi plus pi by 22. And by the way, there is one mistake I've done here, because I'm getting this minus sign. So in hurry I did a mistake. The mistake is this one. This is not the formula for the cosine 3 theta. In fact, this is the minus of this thing. So that you have to be very careful. So here also this will become minus of cosine 3 to the power r pi by 22. So the one minus will be remaining there, and there's a minus 1 here, minus 1 here. And now cosine 11 pi by pi plus pi by 12 is a cos odd pi plus theta, so it will go in the third quadrant, and so this will become minus cosine pi by 22. And denominator already it is inviting to get cancelled, so we can cancel this thing, and that will give you the value 1. And so our answer is 5 minus alpha square. So alpha value is already 1, so answer is 4. So I am in hurry to give you the second method. Second method is a little bit longer, and as I told that I'm going to use the polynomial theory, complex number, and many other mathematics. So if you want to explore that much deeper, or you are a math enthusiast to learn many new things, and then it's okay. You can follow up or proceed to watch the video further. Otherwise, you can leave also. So let's start. So the idea is this, that anyhow, suppose I try to make it into the like a factors of polynomial, then is it helpful? So for that, let me first write this thing. These two terms I'm writing in the simpler version. So this alpha, let me write it first. You notice this 27 pi by 11 I can write as 2 pi plus 5 pi by 11. So I can write 1 minus cos 2 pi plus pi by 11. So the cos will fall in this first quadrant, and so it will give you 5 pi 11. In a similar way, this 81 pi by 11 I can write as 8 pi minus 7 pi by 11. So it will fall in the fourth quadrant, and the fourth quadrant again the cos is positive, so I can write cos 7 pi by 11. Now you can see that every term is there starting from, so what I'm writing there alpha as the product. So let me write it here. We can write the product of what? 1 minus cos pi by 11, then 1 minus 2 cos 3 pi by 11, and till 1 minus cos 9 pi by 11. So now we have a goal. Our goal is to find the polynomial. Let me write it, whose roots are xk. And what is xk? Xk I'm calling 2 cosine theta k, and k is from 0 till 4, or maybe I can write 1 to 5. It looks better. 1 2 3 4 5. By the way, what is theta k? So theta k I'm calling as 2k minus 1 pi by 11. So if I take this theta k, this depending on 2k minus 1 pi by 11. Suppose I'm taking any particular theta for theta k, theta is equal to 1, sorry, k is equal to 1. What do you write? Theta is equal to pi by 11 and so on. So this is our whole setup. Now we'll try to build up. Now notice this one thing, that if I want to find the polynomial whose factors are these terms, it means our roots are going to be 2 cos pi by 11, 2 cos 3 pi by 11 and so on. So how do we start? It means we are finding the different values of theta, and how these different values of theta are applied. Actually, the governing terms are here. Theta is equal to pi by 11. From here we can think that 11 theta is equal to pi. Now can we just set up this 11 theta is equal to pi in such a way that we can form a polynomial of cos? So I know that I can write 5 theta plus 6 theta is equal to pi as 11 theta is equal to pi, and here I can write 6 theta is equal to pi minus 5 theta. So I can write further as cosine 6 theta plus cosine 5 theta is equal to 0. Now this equation has a potential to transform into the polynomial of cosine, and here comes some deeper mathematical exploration. So let's see now what we can do. Now we know that the cosine theta, first term here, cosine theta, cosine 6 theta, I can write this. In fact, is already given in your NCERT book, that how we expand this cosine 6 theta in the terms of cosine actually. So this I can write cosine 2 into 3 theta, and then I can write rather 3 into 2 theta or what. Okay, so I can write there what cosine 2 theta is 2 cosine squared 3 theta minus 1, and cosine 3 theta I can write 4 cosine cube theta minus 3 cosine theta power 2 minus 1. Now if we expand it, we get 16 cosine to the power 6 theta plus 9 cosine square theta minus 4 is to the 24 cosine to the power 4 theta, and that is minus. It will turn into 32 cosine to the power 6 theta plus 18 cos square theta minus 48 cos to the power 4 theta minus 1. So here I am replacing this cosine theta with c for the convenience only. So I got this value as 32 c to the power 6 plus 18 c squared minus 48 c to the power 4 minus 1. So this is our second, and we will use it. So this we got the value for cosine 6 theta. Now what we have to find is cosine 5 theta. So how do you find the cosine 5 theta? That's important. And here I'm going to give you, because here I found this cosine 6 theta with the help of trigonometry. The cosine 5 theta I want to teach by using complex number. Even the cosine 6 theta we can also find by using the complex number, but cosine 5 theta I'm trying to find by using the complex number. So how do we find it? This is actually convenient tool. So I'm finding by using complex number. By using complex number. And in complex number, particularly the De Moivre's theorem or the Euler's, whatever you can say. So I can write rather De Moivre's theorem, cosine 5 theta plus I sine 5 theta, I can write by De Moivre's theorem as cosine theta plus I sine theta, the whole power 5. And now it comes by the De Moivre's law. This is actually a well-known property. I'm going to use the binomial theorem after this to expand it. And you know the idea now. If I expand it further, I will get the terms containing iota and the terms containing free from iota. Means terms free from iota. Means we are getting the real part and the imaginary part both sides, and we are going to compare only the real part because I need only cosine 5 theta to compare it with some terms. So here I'm going to apply the binomial theorem. So this is going to be cosine 5 theta, the first term. Then I get 5c1 iota sine theta to the power 1 and cosine 5 theta to the power 4. So let me write in that way so that you can understand. So what I mean to say is cosine to the power 4 theta and iota sine theta. Then 5c2 cosine cube theta and then iota sine theta squared. Then 5c3 cosine squared theta iota sine theta cubed and 5c4 cosine theta iota sine theta to the power 4, and finally iota sine theta to the power 5. So these are terms actually when I expand it, but notice I need only the terms independent of iota. So what are the terms independent of iota? You can see this term is there, then this term also be independent of iota because there is iota squared, and here also this term will become independent of iota. So in all these 6 terms, I have 3 terms independent of iota. What are those? Cosine 5 theta I can write as cosine to the power 5 theta. And notice that when I expand this iota sine theta square, this will become minus 1 due to the fact that iota square is minus 1. And 5c2 is 10. So I can write minus 10 cosine to the power 3 sine squared theta. And here also we can get here 5c4 is 5 and cosine theta as cosine theta, and iota to the power 4 is becoming 1, so it will become sine to the power 4 theta. Now our task is to transform this whole thing in terms of cosine theta. So we can write this cosine 5 theta as it is, minus 10, and this is cosine cube theta, 1 minus cosine squared theta, and then again 5 cosine theta, and this I can write 1 minus cosine squared theta the whole square. So after this let me simplify this first. So cosine 5 theta minus 10 cosine squared theta plus 10 cosine to the power 5 theta rather. This is 3. So this will become 10 cosine cube theta minus, not minus, plus cosine to the power 5 theta. Then here 5 cos theta, and here 1 plus cosine to the power 4 theta minus 2 cosine square theta. What I have done here, I have expanded it by using a minus b the whole square formula. So we get it here cosine to the power 5 theta and 10 cosine to the power 5 theta. That is going to be 15, not 15, 11. 11 cos to the power 5 theta minus 10 cosine cube theta. Here going to be 5 cos theta. Then plus 5 cos to the power 4 theta, not 4, 5 theta. And here minus 10 cos cube theta. If I just collect all the terms, so 11 plus 5, 16 cos to the power 5 theta minus 20 cos cube theta plus 5 cos theta. So this is the term I got for cos to the power, cos 5 theta rather, and I use this, this is third one by the way. I use this second and third to write in there in first equation. So let me just combine. Then again I'm going to write this cos as in terms of c. So this is going to be 16 c to the power 5 minus 20 c cube plus 5c. So from 1, 2 and 3, from first and second and third, what I'm getting is here is this is cos to the power 5 theta, rather cos to the power 6 theta. I got 32 6 theta, 32 c to the power 6 plus 18 c squared minus 48 c to the power 4 minus 1. Exactly, yes. And here I got plus 16 c to the power 5 minus 20 c cube plus 5c is equal to 0. So this is the polynomial of what I was looking for. So let's call it p as a polynomial, and from there we will think how to do it. So let me just also confirm that my calculation is so far is actually correct, because I've already solved in my tab. So 16 c to the power 4 and so on. Okay, so that's correct actually. After this, what we have to do, that's important. Let's see. You notice when I am looking for this equation, please, this is important. So important is this one. When I'm looking for cosine 5 theta plus cosine 6 theta is equal to 0, you notice what we notice, observe this thing, that theta is equal to pi is automatically a solution. Why? Because when you substitute theta that is equal to pi, that will become minus 1 cos even pi minus 1, and cos 6 pi is cos odd pi minus 1 and cos even pi is 1, so it will become 0. But this theta is equal to pi we don't need actually. Why? If the theta is equal to pi, I have assumed c is equal to cos theta, that c is equal to minus 1. And this minus 1, I am not looking for the equation or the solution for the polynomial, because theta is equal to pi I don't need. Therefore, I will exclude this thing. But one thing from here is confirmed, that c is equal to minus 1 when theta is equal to pi, means c is equal to minus 1 must be a solution for this equation. So it means, let's verify it. So if you want to verify, let's substitute c is equal to minus 1 in this equation p. So we get here 32 plus 18 minus 48, all the even powers are there, minus 1, and this will become minus 16, and the plus 20 and minus 5. So what we are getting there is these two terms going to be 50 and 20, 70, and here minus 48 minus 1 minus 49 and minus 16 minus 65 minus 70, so 0. Means c is equal to minus 1 is the solution, so c plus 1 must be a factor of the polynomial. So c plus 1 must be a factor. So c plus 1 is a factor. So if I try to write in the correct order, means decreasing order of the powers, that will be convenient. So 32 c to the power 6, 32 c to the power 6, then plus 16 c to the power 5, then minus 48 c to the power 4, minus 20 c cube, plus 18 c square, then plus 5c, and then minus 1 is equal to 0. So c plus 1 is a factor, and I have to construct this thing by taking the other factors. Already I have taken c plus 1 as a factor. So we can do it by just taking this 32 c to the power 5 and so on, but I've already done it, so let me write this thing. So 32 c to the power 5 minus 16 c to the power 4, and minus you get 32 c to the power 3, then 12 c square plus 6c minus 1 is equal to 0. It means now we are looking for the new polynomial, what we have here, 32 to the power 5 minus 16 to the power 4 minus 32 to the power 3 plus 12c squared plus 6c minus 1 is equal to 0. Now this is polynomial number star, polynomial star, let's say, and on this we have to work. Notice one thing, what we have to notice, that this has c is equal to cos theta is the solution. But what we are looking for, we are looking for the solution which is 2 cos theta. If you notice this carefully, I am looking for the polynomial which had the solution 2 cos theta, correct? So for that, what we do here, the xk or x is the solution I'm looking for, 2c by the way. It means I can say c is equal to x by 2. And now we substitute this x, c is equal to x by 2 in this. So this will give you 32, x to the power 5 by 32 minus 16, x to the power 4 by 16 minus 32, and x to the power 3 by 8 plus 12, x squared by 4 plus 6, x by 2 and minus 1. So let's simplify further. That will give you what? X to the power 5 minus 16, x to the power 4, 4x to the power 3 plus 12, x, not 12, 3, 3x squared plus 3x and minus 1 is equal to 0. Let me check it again because it's a very minus 4, 3, 3x minus 1. That's perfect. So this is the polynomial we have for which the product of roots, not product of roots actually. So this has how many roots? How many roots we have? Notice 5 roots. And what are those? The xk's are the roots. For k goes from 1, 2, 3, 4, 5. So can we not write this thing as this entire polynomial? Let's say px is this polynomial I have. So can I write px as the factor of its roots also? So x minus x1, x minus x2, x minus x3, x minus x4 and x minus x5. You notice that x1 is nothing but our 2 cos pi by 11, if you can recall this thing. x2 is what? You notice that 2 cos 3 pi by 11. Because all that I have already taken this xk as 2 cosine 2k minus 1 pi by 11. If you can realize this thing, it means what they are demanding. They are simply asking the value of this at 1. It means the value of this polynomial at 1, either you can find from this or you can find from this, it will give the same thing. It means the p1 we are looking for here, so it will give you 1 minus 16 minus 4 plus 3, again 3 minus 1. 16 will not be there, no, sorry. Thank you for just giving me the time to think. Okay, so this will going to be 1 only because the 16 was already cancelled. And so we get here 3 plus 3 is 6 plus 1 7. Yes, so 7 minus 6, that is 1. So we got p1 is equal to 1. So of course I will not recommend this method to give in like apply in any examination setup. I only recommend to explore. Means the, are you actually looking for a teacher who thinks for you, or are you looking for a teacher or looking for any tool which makes you think? So that's important for you to make this discrimination. So here actually the idea is that you can apply this in the examination setup, and to crack the advanced kind of examination or for a correct understanding of mathematics, this deeper understanding must be required in a good student. So I hope you like this second method, not for the speed, but for the depth understanding. So thanks for watching. See you in the next video with some other good examples and good questions. Till then, stay math active.